Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session, we are going to discuss the parallel axis theorem. Here, a brief description of the parallel axis theorem is given. It states if the moment of inertia of a plane area about an axis through its center of gravity is denoted by Ig, then moment of inertia of the area about any other axis AB parallel to the first and at a distance h from the center of gravity is given by IAB, that is the moment of inertia of the area about an axis AB, equal to Ig plus AH square. Here Ig is the moment of inertia of the area about its center of gravity. A is the area of the considered section. H is actually the distance between the two axes. Here it can be defined as distance between the center of gravity of the section and axis AB. Okay. First of all, when will we use this parallel axis theorem? For an example, for any considered area, if you know the moment of inertia with respect to an axis, it may be horizontal axis xx or vertical axis yy, which passes through the center of gravity, that considered as Ig. Then if you want to calculate any other axis AB, that is moment of inertia with respect to any other axis AB, and these two axes, that is the previously the considered axis xx or yy and this AB, these two axes are at a distance h, then we can use this parallel axis theorem. Here I just explain the parallel axis theorem with one example. Here I am going to draw a rectangle. Okay, this rectangle for the considered area. Here we know the dimension of the rectangle, the linear dimension we are going to take as b, which is called as breadth, and then the vertical dimension we are going to consider as d. Okay, this linear dimension we are going to consider as b. Okay, then we are going to take the vertical dimension as d. Okay, it means that this one is b and then this one is d, breadth and depth. Okay, first of all, here we consider the center of gravity of the diagram, or the given area has to be here. Then we are going to consider the two axes. First one is the x axis, which is passes through the center of gravity. Okay, this is the xx axis which passes through the center of gravity. Actually, we know the moment of inertia with respect to the x axis or the horizontal axis which passes through the center of gravity, that we are going to consider as Ig. Okay. And we know that for the given dimension and for the rectangle, if B is the breadth or the linear dimension, and then D is the depth or the vertical dimension, then moment of inertia with respect to the xx or horizontal axis, which passes through the center of gravity, that can be considered as B d cube divided by 12. Okay. Actually, here we know this value, that is moment of inertia with respect to the xx axis passes through the center of gravity. Okay. But we need to calculate the moment of inertia with respect to another axis, which is at a distance h from the previous axis. Okay. Here we considered the another axis, that is actually take us A, B. Okay. These two axes are at a distance, at a vertical distance h. Okay, this one. That is the distance between the center of gravity of the section and the considered axis AB. Or we can say this is the vertical distance between these two axes. Okay. So here we know the value of moment of inertia with respect to the x axis or horizontal axis, which passes through the center of gravity. But we need to calculate moment of inertia with respect to this axis. Okay, we need to calculate moment of inertia with respect to the axis AB. Okay, that is IAB. Okay, that equal IG plus AH square. Here IAB, that is the required moment of inertia with respect to the parallel axis AB, which is at a distance h from the center of gravity or the axis xx or horizontal axis, which passes through the center of gravity. Okay, that equal Ig, moment of inertia with respect to the axis passes through the center of gravity, plus A, area of the considered section. Okay, here for rectangle we know area, that will be B multiplied with D. Okay, that is as per the given dimension. Okay, in case if you consider a y axis which passes through the center of gravity, for that also same case, I just explain it here. Okay, so here we are going to calculate moment of inertia with respect to an axis AB this axis is at a distance h from the center of gravity or the vertical axis y, which passes through the center of gravity. Okay, so we know that the moment of inertia with respect to this y or vertical axis which passes through the center of gravity, that is considered as IG. To make difference, we can consider this as IGY with respect to YY axis. And as per the dimensions given, when B is the breadth and D is the depth, we can consider this as DB cube divided by 12. Okay. Then we have to calculate moment of inertia with respect to moment of inertia with respect to or about axis AB. Okay. That is IAB. That equal to IG plus AH square. Here, IB is the moment of inertia with respect to the axis AB, which is at a distance h from the vertical or YY axis, which passes through the center of gravity. That equal moment of inertia with respect to the YY or vertical axis passes through the center of gravity, IG, plus area of the section multiplied with h, the distance between the two axes or the axis and the center of gravity, square. Okay. So this is the parallel axis theorem. Okay. Okay, guys, don't forget to subscribe for more videos. Okay. Thank you.